Hello, friends and followers. So I'm still trying to fix the second paragon here. I've spent days trying to figure this thing out, which is probably not a great use of my time, especially if I am sick with something and had a limited life left. But anyway, let's not think about that. So the minor loop signal just faded out on me, and I was trying to fix the major loop board. And then I kind of jumped back to the minor loop board. Any rate, so once you finally get the minor loop working again, you can verify it's working pretty easily by putting a receiver, and I'm using an RTL-SDR. So you can see on the major loop board, it pretty much amplifies the 44.7 to 44.75 signal through a FET and then through a bipolar transistor. And right about here on top of this transformer is a good point to pick up a clean signal of what it's trying to use before it gets put into a divider. So right about there is where I'm connected, and that's around wire 88. Anyway, you want to adjust this coil, the minor loop VCO, until you have a dependable minor loop signal on your receiver. So here I'm looking at, and the minor loop is supposed to go from 44.7 to 44.75, and then it keeps repeating that. And so here we take a look, and I'm twiddling with the dial here, and if I just go, say, here, it should just click in. Okay, I clicked into there, clicked into there. Okay, there's 7. Okay, it memorizes where I was. That's kind of cute. So anyway, beyond all that, what if I go to 40 meters here? Okay, now I'm at 40 meters, and the minor loop is drifting around, which isn't very reassuring. But at any rate, so I'm looking at it here, 44.8. So when I turn the frequency knob up, I want to see it go from 44.7, and it's not doing that. Okay, now I'm turning it down, and it should stop at 44.7 and then go back up if you tune down. So that's reasonable. And now it should just go back to 44.75. Well, yeah, there it goes. So that's about right, I suppose. It's not quite on track, but it's pretty close. And that's the action you want to see. And if it doesn't go to 44.75, yeah, so I'm turning the frequency now, there's slop in it, so it's not really, so basically it wants to go a little higher, but it can't. And so that would be the evil VCO here, I think. It wants a little more high frequency, so I'm thinking, I never know which way to turn this thing, but I'll just turn it in a tad and see if that helps it. And you can't turn this thing very much, it'll screw it all up. And this thing is so fragile. All right, a very small turn downward. And let's see what that did to our alignment here. If I can hit 44.75 or not. No, I can't. I can hit 4470, but not 75. So I'm wondering if do I care? Does it really hit 4475? So if I twiddle with the coil a bit, this is so delicate because I don't have the proper tool to tune it. Oh, look at that. So I tuned it upward and now it's locked there. So I tuned it up, whoa, and now it kind of skipped up. So the trick is, do I still have control over it? I bet not. No, I don't. So yeah, so if you lose control of it, go back to where you were, because that means you're unlocked. So boy, it's touchy. Okay, I think it locked there. Yep, I got control again. So 4475, and it should go back to 4470. Well, not really. This thing has been a lot of fun, I'll tell you. No, it's not been a lot of fun. All right, so I've lost control of it there. And now you might go into a death spiral because you're not sure what's going on. Turn it down a bit more. Seems kind of locked. All right, do I have control? Yeah, I do. I turned it in. Okay, there's 70 right there. Okay, look at that. So that's what you want. So 4470 to 4475. And now don't F with it. It's working, it should keep working, I would think. Who knows, this damn thing. All right, so that's what you want to see. That's minor loop is adjusted. So you can see I'm hitting 7 here, I guess, and it's, no, not really. 90. Okay, what if I hit 40 meters now? Okay, there's 80 meters. And yeah, that'll reset correctly. I'm not sure. This still seems off. Like it should work on even numbers or something. So I'm trying to see where it switches here. Right there. It's not real exact. Yeah, this thing is still screwy, but it seems to be tracking somewhat. Now it should switch. Okay, there it goes. So it switches 3.603, 210, 21, okay. Okay, it switched right about there. Kind of watching both here to see when it switches right there. Okay, I go back one and see if it'll switch back. Yeah, it did. So, okay, that's working, I guess. Let's leave it alone. So that's how to tune your minor loop, I suppose. So then I've been trying to fix this thing to get the lock on anything, right? And let's see, on the minor loop, if I change bands now, does it work reasonably here at 28? I mean, it shouldn't care. The minor loop just works no matter what, but let's see if it reacts well. 7.5. Yep, went back to the beginning. It seems to be reasonable, I hope. Anyway, let's assume it's somewhat working. So then, these phase chips here, minor loop board, major loop board, the phase chips on these things. This is like the phase lock loop chip here. Say you get a reference input on pin 1 and you get a divided down reference from the VCO in question here on pin 8. So I'm finally learning this somewhat. It's taking me days of screwing around. So pin 1 on the phase chip. Let's attach to that one and see how things are going. Pin 1 is the little dot. Sorry about that. You don't want to short these out and blow the chip. Okay, I'm on pin 1, and I think that's like a reference voltage, reference signal coming in. From here, I'm thinking, yeah, that looks about right on the scope. So that's good. Pin 8's gonna come from one of these VCOs. And then it's gonna try and interpolate from those. So pin 8, look at that, has a signal also. So you would think we'd lock. And now if I change this band, that signal should change. Which it does. It goes to a lower frequency because we're going a lower frequency here. So that's reasonable. So you would expect that. So now the real bugaboo is then, why don't we have lock on, I think the minor is locking, so why aren't we having lock on the major? And the way this thing works is, it seems like it has to have both locks working, or else you're going to be out of lock. So if this is out of lock, or this is out of lock, you're out of lock. And because it looks like they tie the outputs together, it's hard to ascertain that. So what I'm reading is the out of lock pin on this chip puts out pulses, and how can we tell, how can we get our major to lock? Let's see. So I want to go on the low band here. That's the lower band. And I'm thinking that this thing should just lock now if I just spin it down, and that I have two signals going into the phase lock loop chip on the major board. And they both seem reasonable. So if I look at this signal going on pin 8, which is the oscillator here, the first oscillator, VCO divided down, that looks, you know, rather reasonable. They should look the same pretty much. And then if I look at pin 1, which is the reference signal, I think that's a 2.1 signal, I think, but I forget. Let's take a look. Lots to memorize on this stuff when you're working on it. Okay, there's pin 1, and yeah, so that looks to be the same. I should probably put 2 probes in here and try and match the signals. But notwithstanding, I should be pretty close now to locking. So I'm thinking that with everything present now, I should be able to spin this core down and lock. So I'm trying to figure out if we could do that with the meter or with the scope. I do know that there's a pin on this thing that is used for unlock. So let's find that pin. That's wrong. Okay, here we go. What board is this? Major loop, that's good. So the phase lock loop chip is here, and out of phase is unlock is here, and that goes to pin what? Pin 1, 2, 3, 4, 5, 6. What pin is that? Unlock. 7. 1, 2, 3, 4, 5, 6, 7. Yeah, that's pin 7. So that would be interesting to watch and see if we could see a pulse on it, and then we could try to tune the VCO for the pulse to change. Could probably also look at the charge capacitor and see if that's changing also. Let's see. So pin, what pin was that? 7? Yeah. Pin 7. Right there. That's the unlock pin right there. Okay. Scope doesn't show anything. Okay, because I'm on AC. I want to go to DC here. There we go. Now we're on DC, and yeah, that thing stays high, and then it flips down when we're unlocked. So the first thing we have to do is get some pulses out of it. So the other thing is, this thing is charging this voltage pump. So that is on the very last pins of this chip. I think pin 16 and 15. I wonder if we can use those for tuning it. Here's pin 16 here. And that's our charge pump. And I don't know if we can get that to show anything interesting, but let's go to AC mode and see. Okay, there's AC. We'll crank up the gain here. And that's our charge pump. So I'm not sure it's doing anything. Let's crank the frequency here and see if that changes. Not really. Well, maybe a little bit, but I don't think that's going to really help us. I bet when this thing tries to lock, it's going to be manipulating this voltage. So I might just try an experiment and crank down this core, see if it'll lock, or at least affect that voltage on the first VCO, which is the one we're working on now on that band. All right, let's see if we can manipulate that. I'm going down in frequency. Oh, look at that. Look at that, look at that. So does that mean we're locked? It kind of stabilizes there, doesn't it? So that's pretty cool. So I'm just kind of going like this on the core, and it's sort of looking duckier. We're still not locked, but it made a difference. I'm going to keep going down. It's changing that frequency a lot. All right, well, I think it's dinner time, so time to quit monkeying with this thing. Still not locked, but maybe we'll get it. All right, so thanks for watching. Have a great day. Again, this is the Paragon trying to get the phase lock loop to lock up. Take care.